This time. Good evening, everybody. So, as you know, we are presently studying mechanical properties of solids. So, in last class, I have taught you what is elasticity and how the elasticity, like we can say, is the internal structure of solids, like molecules, how they are present, and what is a bond present between them. So, what is a bond present between them is to say that who makes the molecules to hold together, everybody? The force of attraction which is present.
Intermolecular.
Yes, that is what we used to call it as intermolecular force. And we studied the definition of elasticity. So if I compare steel and rubber, who is having the highest elasticity? Everybody? Rubber or steel? Steel. So we have to prove it also. Steel is having a high elasticity compared to the rubber. So what is the exact meaning of elasticity? Who can come back to its that's what tendency to change, like opposing the change in its shape or size, or who can come back to its original configuration quickly. So that is what is we used to call it as a elasticity. So now we are going to study in our today's class. Again, I'm going to stress with a stress. So we all know in last class, we all discussed what do you mean by stress. So what is the definition of stress you have been written? The internal restoring force per unit cross-sectional area. The internal restoring force per unit cross-sectional area. Unit cross-sectional area, which we used to call it as a stress. So that is what we used to say. What is the symbol of a stress, everybody? Sigma. So sigma is equals to the unit, the internal restoring force per unit cross-sectional area. That is what we used to call it as a stress. So now what is the unit of stress? If you notice it, unit of force is Newton, unit of area is square meter. So this is the unit of stress, and it is a what quantity? Last class I already taught you. It is a scalar quantity or vector quantity? All of you, it is the scalar quantity. And we have studied in the last class first type of stress. Of course, there is several types of stresses. Now the first type of stress is longitudinal stress. So please note it. So now onwards, concepts are very simple. Just we need to have a presence of mind. That's all. But definitely the concepts will be appears in everywhere in JEE and NEET and all. So very small chapters, but the depth of the concepts is very, very wide. So longitudinal stress is two types. What is the two types of longitudinal stress, everybody? One is tensile stress and another one is what, everyone? Another one is
Compressive.
what? Compressive stress. So whatever it is, the stress formula is ultimately sigma is equals to F by A. So that is the formula for stress. So tensile stress means, for example, if there is a rod or whatever it is. So if the two forces are exerting both the sides and they are pushing it, like we can say, trying to stretch the rod, that is what we used to call it as a tensile stress. By the time the restoring force is acting like back opposite to restoring force always acts opposite to the applied force. So this is the force which we used to call tensile stress. Compressive stress means what? The both the sides the force is acting like applying to compress the system of a body. So by the time restoring force will act what? Away from it or towards to it, everybody? It will act opposite direction to it. That is what, if the compressive force is acting, then the restoring force Fr will act in the opposite direction. So in this case also, sigma is equals to F by A. So that is what we used to call it as a compressive stress. So both tensile stress and as well as compressive stress, which we used to call it as a what stress, everybody? Which we used to call it as a longitudinal stress. So now, if you observe here, the next type of stress is the most important one. So just if you are like, you can take any kind of like a rubber, if you are stretching or if you are compressing like a spring, that is what we used to call it as a longitudinal stress. So now, next kind of stress, if you want to understand, so this is the most important stress. That is what we used to call it as a shearing stress. Shearing stress, or we used to call it as a tangential stress. So observe very carefully. So tangential stress. Now, In front of you, if there is any object, cylindrical object, like a glass or something, all of you, if you're having in front of you a water bottle or glass or anything, just place it, everybody. Whatever I will say, you just apply it. So this is what is the cylindrical object or any kind of object in front of you. So try having a length L. Just observe very carefully. Having a length L. Now, what is the shearing stress? Observe here also, what is the formula? Shearing stress sigma is equals to force by unit area only, the same formula. So now, but later we'll study the strain. By the time it is very important. So remember, shearing stress means the force is applying exactly at the edge, the corner. You can notice it either here or here, whatever it is. So try to apply the force with your finger. What will happen, everybody? Notice it, all of you. The contacting to the bottom surface, which is contacting to the surface, will be remain same. But just from that mean position, the body will take little inclination. Am I right or wrong? Verify it, everybody. It will be going like this. Is it right or wrong, all of you? It is not falling down. Am I right, Rudreshwar?
Yes, sir.
So if you apply the force with your finger, try to apply it definitely from the original position. So it will just move some displacement. That is what, let me take it as a delta x. And it is moving with a theta angle. And this is actual length is L. So this is only call it as a shearing stress. Shearing stress means applying the force at the edge, the corner, so that the body will move from the original position to the little inclination. That is call it as a shearing stress. So the shearing stress also, what is the formula? Force per
area.
cross-sectional area. That's all. Not area, cross-sectional area. Now somebody called Narendra. Next, volume stress. Third type of stress is a volume stress. So imagine there is a fluid. Fluid means what, guys? We have two kinds of fluids. What is that, everybody? Gases as well as what? All of you. Gases as well as what? Liquids. Both are called it as a fluids only. Theriyuma, theriyada? At least that you tell me, all of you. So both ways to call it as a fluid. Now, we all people are living in the air. Am I right? Will you all agree with me? We are all living with air. Is it right? Please respond. Now, are you people, your body is experiencing by the, imagine I am standing in the air. Is that the air pressure is exiting, my whole body is not. My body is experiencing the pressure of the air or not? Everybody? Please respond. Is it? Am I audible, Pradosh?
Sir.
Yes. Now you tell me, if you are, now all our bodies, now we are living in the air. Are you people are experiencing the pressure of the air or not? Our body will experience the pressure of the air. Am I right? The force of the air.
Yes, sir.
Yes. So imagine I placed a certain kind of object in the fluid, whatever it is. It is a liquid or fluid, whatever you imagine. So this is the fluid. I placed some object inside the fluid. So now definitely the fluid pressure will experience by this body in all the different directions. So the force per unit area, force per unit area, force per unit area, force per unit area. So every direction the fluid is exerting force per unit area, force per unit area, force per unit area, force per unit area. So that definitely the volume of this object will be compressed, either expanses, whatever it is. The volume of the object will changes or not, everybody? Please respond. All of you. Yes or no? Everybody?
Yes.
Yes. So that is only call it as a volume stress. That is what we used to call, okay? We used to call it as a volume stress. Okay, okay, Murali, just focus on the class. So this is what we used to call it as a volume stress. So when any kind of object is there inside the fluid, so the fluid will exert pressure on that object in all the directions for a unit area, so that the volume of the substance will decreases. Then what is the formula for volume stress? What is the volume stress formula? Again, same thing, which is equals to what? Force per area, cross-sectional area. But now, as it is inside the liquid, you can see the pressure in the liquid is different and the pressure inside the object is different. Pressure inside the object is different. So that is why the pressure changes, the pressure difference, which is equals to, we'll consider as a volume stress, which is equals to, the sigma is equals to change in pressure from the substances to the fluid. So that is what the delta P So delta P means the fluid pressure minus pressure inside the object. So that is only we used to say. So sigma is equals to P minus P naught, which is equals to force by area. So this is the formula for what is that actually? Volume stress. Do you understand, all of you? So three types of stress we have. What are the three types of stress, everybody? Longitudinal stress. Next one is what? Shearing stress or tangential stress. And third one is volume stress. So now, tangential longitudinal stress is two types. One is tensile stress and another one is what, everybody? Compressive stress. These are the types of stressors. So this is what is just restoring force per unit cross-sectional area. That is what we used to call it as a stress. That's all it is. No other definition. Now, for the same stress concept, so we are going to apply. What is the unit of stress, everybody? Unit of stress. Make it quick, everybody. Newton per square
Meter
meter.
square.
Newton per square meter is the units of stress. Now, the next concept which we are going to study is all about a strain. So strain means it's a very simple. Note it, because of stress, whatever the change in dimension, either compression or expansion or the position changes with respect to the original dimension. Original dimension, that is what we used to call it as a strain. So all of you observe very carefully. Strain means what? Change in dimension divided by original dimension. Change in dimension divided by original dimension, which is known it as a strain. So can you tell me what is the units of a strain? Anybody? Both similar quantities are divisions.
Dimensionless.
Yes. So it is having no units. Already chapter 1, units and measurements, I have taught you. Do you all remember, everybody? Stress and strain
sir.
also studied? Yes. So that is what you have to remember. Now, so what is this strain? That is only call it as a deforming force. So what change is happening in the body from the original dimension? That is what we used to call it as a strain. The change takes place in the shape of the body, size of the body with respect to the original dimension. That is only call it as a deforming force. That is only call it as a strain. So now let us discuss what is the longitudinal strain first. Okay, so now we all know longitudinal stress is there. Same way, strain is also three types. So what is the first one, everybody? Longitudinal strain. Second one is what? All of you? Shear strain. And the third one is what, all of you? Volume strain. Okay. So let us discuss one by one. What is that? So for this, no need to struggle anything. It's very simple. From a book itself, we can study. There is a beautiful images given in our book. Just you all observe and you can make it this very simple. So now you can see initial length is L. What is the initial length of the rod? Everybody involved in the class and you can make it is very simple. What is the initial length of the rod? Everybody. What is the initial length of the rod, all of you? L. Am I right or wrong? So because of compression or expansion, whatever it is, it doesn't matter. So length may decreases or length may increases. So the strain symbol is epsilon E. So the strain is equals to change in dimension. What is the length changes, everybody? How much it is changes? Before it is L. Now how much it is increases? Delta L. So change in dimension is delta L with respect to the original length. That is what? Original dimension L. So this is only call it as a, what strain we used to call it as? All of you. Longitudinal strain. Is it okay, everybody? Understand, Rudreswa? Clear? Pradosh?
Yes, sir.
Longitudinal strain means delta L divided by L. Original length is L. Change in length is delta L. Either it is compression also, expansion also, doesn't matter. Next, second one is call it as a shear stress. Book you no need to see, just you observe very carefully. This is the initial length, initial position. So because of I applied the force here, so it has been taken, you can see the force is applied, so it has been displaced from the original point. See, initial point is here only, you can notice it. So what is this force? Can you tell me, anybody? The applied force is here. Then what is some force is acting backward direction and the object is started moving forward? What is that force we used to say? Yes, please. The force when the object is trying to move forward, there is a force which is acting backward. What is that force?
Frictional force.
Frictional force. Do you understand, all of you? So that is what we can say is, now if you observe here, you all can notice it. Delta x is the displacement which has been shown from that. Now, observe this alone, you all can see this alone, if you notice it, it is a right angle triangle. Paakranga ellame. Is it right angle triangle or not? See that, Rudreswa, Pradosh? It is a right angle triangle or not? So this is the L and this is the delta x. So shearing stress. And what is the angle here? Anybody? What is the angle, guys? Angle between
Theta.
them. You can see that.
Theta.
Theta is the angle. So the shearing stress is equals to, very simple, change in position divided by, that is what L we can say. So epsilon is equals to delta x divided by L. So if you apply, this is the right angle triangle, delta x by L is equals to some trigonometric function. Can you tell me what is the trigonometric function? Observe very carefully and tell me. What is the trigonometric function? Adjacent side divided by opposite side. Sorry, opposite side divided by adjacent side. What is that? All of you. There is a function which you can notice it. Not
Tan.
yes, tan theta. What is the tan theta formula, Pradosh? Tan theta is equals to what?
Opposite by
Opposite divided by, yes, please, adjacent. So what is the opposite side? Delta x divided by L. So that is what which is equals to tan theta. That is what you have to remember. Now, in mathematics, there is a phenomena. If sine theta or tan theta, remember everybody, the theta is extremely small, extremely smaller, then sine theta become theta and tan theta is also considered as a what? Theta. So if the theta is extremely small, that is what? Tan theta is approximately equals to theta. So that, what is that, everybody? Epsilon is equals to delta x by L, which is equals to what I can consider, everybody? Which is equals to what? Please respond. Which is equals to theta. So that is only call it as a shear strain. So shear strain is equals to delta x divided by L, which is equals to theta. This is what is the formula. Please learn it. Have you all understand, everybody? Please respond, guys. All of you understand, Amma?
Yes, sir.
That is what. So if the theta is very, very small, for sine theta and tan theta, we'll consider is equals to theta. And here, can you tell me theta? What is the units of theta? Angle. What is the units of theta? Radians. Note it. Theta will be what? Radians. So this is what is about shear stress. Now volume stress. So initial volume is V. After compression by the force per unit area, by the fluid, force per unit area by the fluid. So what will happen? The change in volume is delta V. So what is the shear? Volume strain is equals to, everybody? Volume strain is equals to, what will happen? Epsilon is equals to change in volume delta V divided by original dimension is V. Understand, everybody? Change in dimension divided by original dimension, that is what? Volume strain. So these are the three types of strain. One is longitudinal strain, next one is shear strain, and next one is volume strain. So if anybody is having any doubt, you can ask me, I will explain, or else you finish it. Anybody tell me? Are you clear, everybody? Now, shear stress, there is another example also. You take your physics book, or you can take mainly like a dictionaries, basically, if you notice it. All of you observe very carefully. If you are having a long book like this, many of you are having, your physics book may not come, but definitely many long books or dictionaries and all you can see. If you try to apply the force in a forward direction above that, you can see all the pages one after one, from the initial position, they will start moving forward with the theta angle. Am I right, Rudreshwar? Do you all notice that? Yes, please. That is only a body subjected to the shearing stress. That is what they are saying. So this is also which is subjected to the shearing stress. See that the bottom pages will be only here only, but you can notice it. All these pages, remaining pages are moving little bit forward with the theta angle. So the theta is approximately equals to tan theta. So we'll consider delta x divided by L, which is equals to theta. So that is only call it as a shearing stress. So please remember, this is what is about, sorry, shearing strain we used to call it as. So please remember, the volumetric strain is delta V by V, but you notice it, but there is no change in shape. That is very, very important. Before also shape is same, the now also shape is same, but only what is changing? Anybody can tell me? That is the most important point. What is that actually? Delta V by E is the volumetric strain, but what is not changes? Everybody notice it. What is not changes? The shape is not changes. Shape is remains constant. That is the most important point. Understand, Kadir, Laksha? Everybody clear? Please respond.
Yes.
So that is what is about what is stress and what is strain. So from that finally I'll make the conclusion. So stress is equals to single formula. Whatever the stress it is, what is the formula? Force per unit cross-sectional area. But strain means three formulas we have. What is that? Change longitudinal formula and shear strain, and which is equals to change in volume, volumetric strain. So this is what we used to call it as a stress and strain. So I hope you all understand. Anybody having any doubt, you can ask me. So even volumetric strain also we can call it as a hydraulic stress. So please remember that is what the magnitude is equals to the hydraulic pressure which were applied in force per unit area. So hydraulic stress is also we can say volumetric, that is what? Hydraulic pressure is also we can say volumetric strain. So please note that, everybody. So whatever, because there also the pressure is applied uniformly in all the direction, so that the change does not change. Only volume, the shape is not changes, only volume will change. So that is only call it as a delta V by V is actually the volume strain. So please note it, everybody. Do you all understand, everybody? Clear, Amma? Yes, please. And both are same dimensions. That is why strain does not have what? No units, or it does not having what? Please respond. No dimensional formula. I hope you all clear till here. Anybody having any doubt, you can ask me. Any doubt? Sai Karthik, Manya and Samya, Rishi, understand, everybody? Yes, please. All of you?
Sir.
Yeah. So this is only
Yes,
we
sir.
call it as a volumetric strain. Now, as I said, everybody, now all of you remember, everyone, the stress and strain is always both are directly proportional to each other. If the stress increases, then strain is also increases. That is what a stress and strain both are directly proportional to each other. So now, if you notice it, all of you. So for example, if I say, so if I take a spring, for example, where the spring is attached it. So there is a capacity for a spring. So I attached some m amount of mass. So by the time the force which is acting downward direction, weight of the body, and there is a force which is acting upward direction. What is the force we used to call it as? When the weight of the body is acting downward direction, then what is the force which is acting?
Spring force.
Spring force, which is called it as a what, Rudreshwa? Restoring force. Understand, everyone? Restoring force. Now, this m become one more m become one more m become one more m. Then this force is keep on increases. Am I right or wrong? Weight of the body is keep on increases or not? Everybody? Yes, please respond.
Yes,
If
sir.
the weight of the body is keep on increases, then the restoring force also keep on what? Keep on increases. Now, once there is a certain limit for it, once this mass is keep on increases, by the time what will happen? Is it possible to restore the spring back if you remove the mass? Yes, please.
No.
No, that is call it as a yield point. You can notice it. The maximum point, proportional limit. Once the strain and stress, basically both are directly proportional to each other. At times they will cross this proportional limit. By the time, what will happen? Permanent change will take place. You all can see that. Permanent change will take place. After that, if I remove the mass also, is the spring will go back to the original position? Everybody, that is what is my question. Is it possible?
No, sir.
No. Then After that, again, it will be extension. Real life, imagine extension. Certain up to certain mass, if you release the mass, it will go back to the original position. Once if you cross that point, that is the point we used to call it as a proportional limit. Now, once if you cross that, and if you are keep on adding the mass more and more, then the spring will start stretching. So it will attain the what, everybody? What it will attain? Permanent set. Do you understand, everybody? So once the mass will becomes to certain limit, so at that mass maximum, so it will attain the maximum stretch. Fully it is elongated. So there is no, if you remove the mass also, it will never be go backs. Do you all understand? Pradosh, Laksha, anything doubt? Anybody can ask. Are you clear, everybody? Please respond. So real life example I will take. For example, all of you observe. Understanding concept is very important. Most important graph. Imagine now I kept 5 kg mass. Now I keep on increases. So weight is acting downwards, which is equals to F is equals to what? 5g. Am I right? Yes, please respond, guys. Weight is equals to 5g. Is it right or wrong? Now upward also stress is equals to what? Tension. The applied FR. FR means what? Restoring force is equals to tension in a string. Am I right? Yes or no, guys? Please respond. So now 5 kg become 10 kg, 10 kg become 15 kg, 20 maximum become 20 kg. So up to 20 kg, the spring will start elongating, coming down. Of course, the strain also increases, stress also increases. But if I remove the 20 kg, the spring will go back to the original position. Now, if I increase the 21 kg, 22 kg, 23 kg, after that, the spring will attain the permanent set, so that if I remove my mass also, the spring will never go back to the original position. Are you trying to catch my point? What I'm saying, everybody? Please respond, guys. Are you clear?
Yes,
So
sir.
now from 21 kg to 23, 24, up to 25 kg, the spring will still elongate. But what is the problem we not notice? Up to 20 kg, if you remove the mass, it will go back to the original shape. But from 21 to 25 kg, elongation will be there. Extension of the spring will be there. But what you are not noticing, everybody, if you remove it, what will happen? It will not go back to the original point. That is the point we used to call it as a yield point. Understand, Rudreswar, what I'm saying? Means from A to C, you all notice it, where elastic limit will gone. Are you clear, everybody? So if you remove the load, the dimension cannot be get back. The original shape cannot be bring back. That is the point we used to call it as a, what we used to call? Yield point. So after that, what will happen? If you increase the weight to 25, 30, 35, 40, 50, 55, still there is no extension of spring, but it can hold it or not. That is what is my question. Do you all understand it? It can hold it or not? Everybody, it can hold it. So now up to 50, example I'm saying, no extension of spring, but it can hold the weight. It can hold the weight. But once, if it reaches to, example, 50 kg, if I keep 51 kg mass, by that time, it will breaks. What will happen? Up to 50 kg, it will hold the mass without breaking. Once if I go more than that, you can see what is happening, everybody. What is the point here? Notice it. Fracture point. So the point A and point D, both ways to call it as a proportional limit. Up to here, what is the proportional limit? They can attain the shape back if you remove the mass. Now up to here, the shape cannot be get back, but it can hold it without breaking. But if it goes more than a D, what will happen? By that time, it is already crossed the understanding stress or strain over everything, so that the spring will breaks. That is what fracture point we used to call it as. So after that, what will happen? The spring will cut. So this is what is the typical stress strain curve for a metal. I hope you all understand. Extremely important one. Do you all understand, Pradosh, Rudreswar? Yes, please. So where the body, you can see. So if there is, if you are keep on increasing further, the stress developed exceeds the yield strength, and strain increases rapidly even for a small change in the stress. the portion of the curve between B to C shown this. You can see that B to C, what will happen? There is a drastic changes in the strain, so that after that the shape cannot be get back. Permanent changes, permanent set will be takes place once it will reaches to the what point? Everybody, you can see that. What is the point? Permanent changes will happen. No spring will go back to the original dimension. Everybody? Yes, please. Point C. Are you clear? So up to point C, there will be extension of spring or not? That is what is my question. Spring will extend or not? Yes, please. Spring will stretch. But if I release it, what will happen, everyone? The material will never deforms back into the original position. What will happen? It reaches to the permanent set. The material is set to have a permanent set. So further, if you remove the mass also, it will never go back to the original position. So like that, I'm keep on increasing mass up to certain D point. It can hold the mass without breaking. So that is the physical property you studied in 8th class or 10th class also. Tensile strength. Do you remember, Pradosh? Tensile strength, holding capacity. Am I right, girls and boys? Respond. So up to from C to D, you can increase the mass also. It can uphold the weight, but it won't break it. So once it will reach us to the maximum point D, that is what we used to call it as the point which we used to call it as ultimate tensile strength of the material. So once beyond this point, what will happen? Additional strain is produced even by reduced applied force, and fracture occurs at the point E. So once the point E occurs, what will happen? The spring will break. That is the point we used to call it as. Everybody? What we used to call? Brittle in nature. What do you mean by brittle? Anybody tell? Any girl or boy? What do you mean by brittle in nature? Breaks. Understand, Amma? It will break. So if they are far apart, the material is said to be basically up to here, the materials are up to ductile. They are having a high tensile strength, metals. Once it will goes more than that, the fracture point will occur. Means the material will breaks. That is what we used to call it as a typical stress strain curve for a metal. Now, as I said, you stress increases up to here. Stress is directly proportional to what, everybody? Strain. So proportionality constant I am removing. I will bringing the constant K. So stress is equals to K into strain. So this is only call it as a Hooke's law. So please note it, everybody. So what is Hooke's law, everybody? All of you? Stress and strain are proportional to each other. Stress and strain are proportional to each other. That is only call it as a Hooke's law. Actually, Hooke's law means also we can call it as a elasticity. So elasticity only, that is what stress increases, strain also increases. That is only call it as, what is to say, everybody? Please respond. All of you, Hooke's law. Clear? So what is Hooke's law? So we'll derive the formula also. So this is what stress is equals to. Stress is equals to K into strain. Basically, this K naught, this K is only, we used to call it as a modulus of elasticity. The symbol of modulus of elasticity is E. Please note it. And actually, it is a epsilon. You can write E also. Note it. The K or E, whatever it is. So K is equals to, what is the formula? Stress by strain. Note it, everyone. Or we can say E epsilon is equals to stress by strain. And what is epsilon, everybody? What is epsilon is equals to? Here you see that. What is epsilon? What is epsilon?
Modulus of elasticity.
Modulus of elasticity. Or note it, Pradosh, constant of elasticity. Or you can see constant of elasticity or modulus of elasticity, both are same. This elasticity is purely a property of material. It is not same for different materials. Different materials is having different modulus of elasticity. I hope you all clearly understand. Small doubt up to here, you please ask me. If you not understand, again, I'm ready to say. If you're having any doubt, you can ask me. So now, can you tell me what is the dimensions of a modulus of elasticity? Make it quick. What is the dimensions of modulus of elasticity? What is the formula of modulus elasticity, everybody? Modulus of elasticity, what is the formula? Stress divided by, tell me guys, stress divided
Stress
by
by-
what? Strain. So what is the unit of stress? Newton per meter square. Units of strain? No unit. So units of modulus of elasticity also, what is the units? Everybody. Modulus of elasticity also, what is the units guys? Newton per meter square. That's all it is. Okay. So please write it. Any doubt, anybody can ask me. If you understand this, then I'll proceed further. Till here, I hope you all understand. Padosh, Rudreswa, everybody clear? Please go through that. Every line you don't believe. When I'm preparing for JEE, for NEET, for NCRT, line to line, I am taking a step. Like 10th class, how I have given you the care. At least from volume 2, I need to be like that. That's the reason I'm keep on NCRT. I'm also involving. Why you know? So volume 1, I never use NCRT. Of course, I touched. Is there any concepts I left, Rudreswar, in volume 1? I think 99% cases I covered all the things. Am I right? Yes? Anything
Yes,
else for those? So that's what. Now I want to be more even efficient. That's the reason I'm including everything. So please go through that and learn it. It's very simple concept. If you have